This lesson will show how to use Desmos.com to graph a binomial distribution and determine probability. In the United States, there is an 18.33% chance that a woman will die of cancer. If 20 women are selected at random, determine the probabilities below. Give the answer as a decimal to 3 decimal places and a percent to 1 decimal place. To begin, we need to recognize we do have a binomial experiment, which we discussed earlier, with the following characteristics. If you need the review, you may want to pause the video and read these characteristics. Let's begin by graphing the binomial distribution. To do this, go to Desmos.com and click Graphing Calculator. In cell 1, we can either type in binomial dist, or we can go to the Desmos keypad by clicking the Show Keypad button in the lower left-hand corner, then click Functions, click the Distribution menu, and click Binomial Dist. Now we enter the number of trials followed by the success probability. And for our example, because 20 women are selected and we're trying to find the probability of a certain number of women dying of cancer, and as a number of trials, and the success probability is 18.33%, which we must enter as a decimal. Going back to Desmos, we type in 20, 0.1833, which is 18.33% as a decimal. Let's close the Desmos keypad. Let's adjust the window by clicking the Zoom Fit button, which is the magnifying glass below the red circle. And now we have a nice graph of the binomial distribution. If we want to change the color of the graph, we can click and hold on the red circle and change the color. Let's go ahead and select purple, click outside the menu to close. From here, if we want to click on any of the points, we can find the corresponding probability for that number of women dying of cancer out of the 20 selected. So for example, if we click this point here, notice the ordered pair is 2, 0.1668, which indicates the probability of 2 women dying of cancer out of the 20 selected is approximately 0.167 or 16.7%. But our first probability is to find the probability that 7 or more women will die from cancer out of the 20 selected. To find this probability, we click the Find Cumulative Probability box, and for 7 or more out of the 20, 7 is going to be the minimum tab and 20 will be the maximum, and the corresponding probability shows below, which is approximately 0.058 or 5.8%. If we take a look at the graph, the closed points and vertical line segments represent the successful outcomes of having 7, 8, 9, 10, and so on, all the way out to 20 women dying out of the 20 selected. It seems odd to refer to the percent dying as a success, but in this case, that's what it would be. Let's go ahead and record this. Next, we want the probability of 5 or less women dying of cancer out of the 20 selected, which means from 0 to 5 women dying. So the minimum is 0 and the maximum is 5, and the probability is approximately 0.855 or 85.5%. Again, looking at the graph, notice how we have closed points when x is 5, 4, 3, 2, 1, and 0. If we were to sum these probabilities, we would get this cumulative probability of approximately 0.855. Next, we want the probability that from 2 to 8 women will die of cancer out of the 20 selected. So now 2 is the minimum and 8 is the maximum. Which to 3 decimal places is approximately 0.899 or 89.9%. And for the last example, we have the probability that 4 women will die from cancer out of the 20 selected. To find this probability, we set both the min and max to 4, which gives us approximately 0.214 or 21.4%. Going back to the graph one last time, notice how if we click on the x value of 4, it does give us the same value, in this case, rounded to 4 decimal places. So the probability of 4 women dying of cancer out of the 20 selected is approximately 0.214, which is equal to 21.4%. I hope you found this helpful.